on the landing page for this repository, and as I said, I'll put this in the thread for our class. Let me just do that. So underneath where I posted the Zoom link, I put a link to this repository. We're going to be working out of this very heavily. Our entire schedule is here, as you can see if you just on the landing page look at this. So we've got important links, the Zoom link, right? We've got a link to just our YouTube channel in general, and also to a playlist that has no videos in it yet on YouTube for recordings of this class. And I'm going to talk about that in a little bit. But within a couple days of class, we're going to put our recordings up here. They're going to be publicly facing. And yeah, that's something we'll talk about in a minute. There's also a link here to our specific Learn cohort, which I didn't need to open that again because I had it here. But we'll tour through this in a little bit. So I'm just going to say something about these slides. The slides here, they may look very simple, very, we actually transitioned from some fancier looking slides into this very sort of simple representation. This is a markdown document, and all of these can be found, all of these markdown documents, which actually look like this, because they're written in a document formatting language called Markdown. They look like this in a regular text document. They look like this. They look like this in VS Code, which is what I'm going to be presenting them from. And these are also available directly in the GitHub repository under slides. And today we're doing welcome.md and introduction to python.md. We probably won't finish out this one. This is has some very basic Python materials. Python basics will be, we'll start those in the next day. But if we look at this, these are rendered in a fairly straightforward, readable way, slide by slide. So, don't be surprised if we present slides out of GitHub. Don't be surprised if as we are lecturing out of these, let's say I notice a typo, I might actually just jump over and fix that typo, oh, actually, here's a typo, right? I can do that. And because I have these pipes in these other spots, very minor typo. So that's something that I might do from time to time. Okay, so what we're going to talk about, or what I'm going to talk about before I hand off to Clark, I'm just going to give an overview of what this course entails, what we expect, or what our goals are for you for this course, and what we expect you, how we expect you to perform in the technical interview, and where you can best find resources for that in our materials and potentially elsewhere. Then we're going to talk about the materials in the course itself, touch on study halls and mentoring, how we approach those two ideas. Clark Walker, who's in here right now, he's one of the people who leads study halls. He's the primary person who leads study halls, although we might be adding other supplementary streamed facets to our program pretty soon. And we'll talk, a little more in depth about the technical interview, and also about the mindset that we expect you to cultivate, right? And when I say that, it's not that there's a single mindset when it comes to development, like technical development, or when it comes to data science or something like that. But there is a learning mindset that is pretty necessary in the data science immersive, and I'll speak to that a little bit. And then, we'll just take a quick look at 3 basic technologies that we're going to be starting with. Learn, which is our learning platform, Replit, which is just a place to run code, and Google Colabs, which is another place to run code, but in a slightly different paradigm. And we'll talk a little bit about how to interact with Slack for this course. Okay, so course is 5 weeks. The schedule is Monday through Thursday, 6 to 8 p.m. Pacific time, as you're probably all aware. But and then Saturday 11 to 1 or 1:30 p.m. Pacific time. Now, this is a decision that we're going to make as a group, whether or not we add an extra class on February 22nd, or if we extend our Saturday classes by half an hour. We're going to do one of those two things. And I'm personally in favor of just adding, another Monday class on February 22nd to make up for the holiday. But either way, I'll probably just put a poll in the Slack in the next few days and let you all decide, because, I'm good with it either way. But a lot of people have a hard time meeting this having a 2.5 hour class instead of a 2 hour class on Saturdays. So I want to leave that to everybody in here. In terms of, in this overview, we've got this premium prep links, and this hopefully just leads to the repository. Oh, no, it doesn't. Okay, you know what? That's something I'm going to fix, because that's not accurate. So I'll fix that in a little bit. Link to the Zoom meeting. If you're here, you already have that link. It's always going to be the same Zoom meeting, same password. And then here's just notes on our team, right? So Clark is going to be your Python instructor. I'm going to be your stats instructor. It's not going to be a hard line, really. Clark is going to talk about a bunch of mathematical and statistical concepts. I'm going to talk about a lot of Python concepts, and all of the stats that I'm going to be doing is going to be through the lens of Python, except for one day, which is going to be a pen and paper day. But that's only one day out of all our class days. Everything else is going to be rooted in Python, and that's a choice that we made as a team to deliver things in this way. This is a list of the people on our team. I'm Tovio. There's Lance, Remy, Devin, and Clark. And our team lead is David. David is not technical. He is technical, but his domain is a different domain. So I wouldn't ask him questions about Python. He's not a Python developer. He's a full stack developer and software engineer in different technologies, not as a data scientist. But the rest of us are data scientists, software developers, applied math or stats people, and so we're all our team right here. We're all qualified to answer any questions related to materials as we go through them. And any one of us might mentor you at any time, depending on your need. Okay, so lecture etiquette. Just while you're in Zoom, we prefer that you have your camera on. We find that to be, we find people to be more engaged when it's like that, and it's kind of nice seeing people's faces. I don't know. There is this way, especially in the era of COVID, that we're all these anonymous names somewhere elsewhere. And so it's not a requirement by any means, but it's nice if you feel comfortable doing that. When you enter into the Zoom meeting, please mute yourself by default. In general, the only person talking in the class is, except in specific time boxed ways, the only person who is going to be talking is the instructor. And for the most part, you're going to be communicating with us via Slack, right? So if you have a question, that's going to go into the Slack thread corresponding to this class. This posted class. So I'll demonstrate that in a second. Actually, I think I already did. If you look in Slack where it says @channel, hi all, classes starting in 20 minutes, etc., notice there's a reply under there. In general, we're going to contain all communication regarding a class in this thread. So I'm just going to type something in there. I'm just going to say only ask questions in this thread, please. So
hey, Tovio, real quick.
Yeah.
Do you want to screen share while you do that? Just so it's or screen share your Slack while you do that?
Oh no, I'm going to get to that. I'm going to get to why I'm not screen sharing my Slack right now. But yeah, if y'all look into Slack thread, just ask questions in the thread related to the class that's posted for that time. And before Clark brings up something that I did want to bring up, and I sort of forgot. We've transitioned all of our materials into this GitHub repo very recently. Okay, so we're teaching in a slightly different paradigm than what we were doing before. And one of the things about that I'm going to talk about shortly is that we're going to be posting recordings of class to YouTube, and they're going to be publicly available. So there's a level of anonymity that we want to maintain, and that's where Clark and I are fine being exposed, but we want to make it very clear that we are not going to expose any of you or your names. Images from Zoom, images from Slack, anything like that. That's we're not going to do that. And if you do see us do that, please say something. Please DM me or please DM Clark so we can trim that out of the recording when we post it. Okay, so in terms of, let's finish up this lecture etiquette. Be appropriately dressed. It may seem weird that I'm saying that, but there have been a couple times where somebody would have their shirt off and their camera on. I don't know. I don't know. It's weird. Not whatever. I'm not even gonna say any more about it. It's a class. It's a professional space. Treat it like that. Feels funny saying that. And like I said before, please limit questions to the lecture thread or to allocated time. Every once in a while we'll allocate time. And if you feel comfortable coming off mute in those allocated times, and we say, hey, if anyone wants to come off mute to ask a question, then just know that your voice is going to be in a recording that is posted on YouTube. No faces, no names, nothing like that. But it's up to you whether you feel comfortable with your voice being in that space. Otherwise, we feel great about you asking questions in Slack and us answering them verbally. That's something that we've been doing this entire time. So, yeah, and this is just restating what I just said. All the recordings will be on our YouTube channel. There's going to be a specific playlist that I linked from above. We're going to continually update this GitHub repository. This is going to continually receive, as we modify things. There's a couple lessons I'm thinking about writing. So, what you might see in the slides, this structure might change as we go forward. And in fact, I'm sure it's going to change as we go forward. And, we're going to be teaching out of these, but the order of them might be altered. In fact, the order of, the schedule out here might be altered as we go, but we're going to update it in general. Question, can we turn off our cameras during the lecture, but turn them on for Q&A and discussion? Absolutely, and it's not a requirement for you to have your camera on. It's more that it's just more engaging. I think people feel, like, hey, we're all in this together. I think that's part of it. And there are times where, like, I know for me personally, if I'm in a class, something like that, a remote class, I feel more engaged if my camera's on. Like, oh, I'm, like people might be looking at me, something like that. It's easier for me to not, jump on Twitter or something like that, which is a very easy thing for me to do, as it turns out. Okay, so yeah, and as I said before, we're going to honor privacy. We're not going to share names. We're not going to share student contact info, anything like that. Okay, let's see. I'm just looking at your question. Oh yeah, right. Yeah, you're doing one of these. Yeah, that makes sense. It's really up to you. And yeah, I've been there. It's like I have two monitors, and I'm always looking up in everybody. You're gonna see me always looking like this, and I'm talking with you. That's just part of the the age we live in with multiple monitors. Okay, so yeah. Okay, so goals. What are some of our goals? Our primary goal is in recognition of everybody coming from a different background, right? I have a software engineering and language studies background. Somebody might have a molecular biology background, or a civil engineering background, or an English background, right? Like we're all coming from different places. And the idea of this prep course is to get everyone to a baseline of skill that they can pass the technical interview. We use our technical interview as a gauge as to someone's current capacity. Let me say it like that: someone's current capacity to be successful in the data science immersive. If you pass our technical interview, it's like, well, you meet our minimum bar for entry. We're not trying to figure out who's amazing at everything. We're trying to figure out, does an individual have the capacity to go into the DSI and get out what we want them to get out of it, right? Which is, employability. It's, what we want people to get out of the DSI, employability, success in the program itself, enjoyment of it, not feeling like you're absolutely constantly underwater, but only that you're maybe lightly drowning as you go, which is actually, I'll talk about that a little bit in a bit. And everybody's going to take a different amount of time, and because of that, we perpetually keep premium prep open for you, right? If you're registered now and you fall behind and you're feeling overwhelmed by it, and you want to slow down your pace, maybe just watch recordings at your own pace and then enter into the next premium prep, you can definitely do that. You're just going to reach out to me or reach out to Clark and say, hey, can I be added to the next premium prep? That's absolutely okay. People take any amount of time to enter into the DSI. I know people who have studied a year and a half to go into the DSI. That's not that uncommon. And that's not to say, hey, you're going to need to do that. It's just everyone's coming from a different background, and some people want to build up their quantitative skill or become sort of amazing at Python development prior to the DSI. And we don't discourage that at all. We encourage you to take the time that you need that allows you to be most successful in the DSI. And because of that, we perpetually keep prep open to you. That said, most people are going to have the capacity to say, go through prep and take a few weeks and, maybe immediately after, when prep is ending, take the technical interview, or other people might take a few weeks to pass the technical interview. It's a little more rare that somebody needs significantly more time than, this 5 weeks plus 3 months or something like that. It's not out of the question. There's nothing wrong with that. But everyone's coming from a different background. Our jobs, Clark, my job, everyone on our team, we are here to be shepherds for people into the DSI. And we're going to work with you at the level that you're at. That's not always going to translate perfectly well into this course, right? Because we have a set of materials that we're going through. But between this course and outside the course, that's how we address everyone's needs, or we do our best to address everyone's needs. The materials in our premium prep are the same materials that are in basic prep. Although I say that, but we also have a couple lectures that, give the basics of machine learning, for example, give a basic workflow for machine learning, or cover some other facet of, let's say, an algorithm like logistic regression or k-nearest neighbors or something like that. Or maybe we dig into permutations and combinations from a different angle, right? So it's not that all the materials are parallel. All the materials that are on Learn are parallel. All the basics of what we teach are parallel to what's in the basic prep. We do monitor you in your progress, right? So we pay attention to your progress through the Learn materials. And it's very likely that, if you are much further along and we see that, if you have high completion, or the code that you're posting in the Slack channel during code challenges, if it's really solid, we might say, hey, you seem like you're ready to pass the technical interview. Let's say this is in week 3, and we're going to be like, hey, take the technical interview, because if you pass it, then we can give you other materials to work on, right? There's a couple books that I recommend to people when they're when the premium prep is a little bit more rudimentary than where they're at, right? Because for us, it's like, we want you to get the technical interview out of the way. so that you can start studying the stuff that's super fun and directly related to what you're going to be doing in data science. Cool. Here's a sort of pat statement. Interview as soon as you're ready. We really mean that. You know, we don't need you to destroy the interview. We don't need you to like make us feel in awe of your abilities, right? We just need you to pass the interview in order to demonstrate that you have the capacity for the DSI. And you know, that said, I'm just going to reiterate: when you pass the technical interview, we give you another set of materials to work on in prep for the DSI, and we can also hone your studies in towards something domain specific, right? So somebody reached out to me and was talking about having an interest in natural language processing. And if you have that interest, I can definitely point you at some materials to give you like a solid primer in natural language processing, so that when you are in the DSI, you can mold your capstones to those kinds of materials, right? Or if it's image processing, that's the domain where I have the most strength. You know, I can give you materials to work on that will directly, impact your capstones in the DSI once you're in. So that's why we want you to get the technical interview done with as soon as you're able, as soon as your Python is strong enough, as soon as your quantitative understanding is strong enough. In terms of expectations, our primary expectation is really work toward completion of the challenges on Learn, right? Work toward completion of those. And the reason I say that is we see a very high correlation between Learn completion and passing the technical interview. In fact, we are constantly scraping Learn and looking at people's completion. And if their completion is above a certain amount, we send them emails and we say, hey, listen, you should probably take the technical interview, because your completion, especially if it's within a small span of time, you're probably sitting in a good spot. So that's our primary expectation: complete the materials on Learn. I say we expect you to attend lecture. Attending lecture is not as important as understanding the materials. And we're all adults here. We don't take attendance, but we do pay attention to the work that you're doing, right? And we always want to see you progressing, developing, and we're going to be available for you to check in, to get yourself unstuck, to clarify things in either the materials or regarding the DSI. This is all just to say, try to attend lecture, and you don't need to let us know if you're not going to make it. But if you get lost on a concept, check in with us about it, and we can tell you, oh yeah, it's in this lecture, and give you a link to that, right? So it's better in real time because you can ask questions in real time, and it focuses your study. Complete homework. I think that just goes along with completing Learn materials for the most part. Ask questions when you're stuck for 10 minutes or more. So if you are on a challenge in Learn and you've just been working on it for 10 minutes and you can't figure it out, you can't seem to figure it out, ask in the channel, right? Don't wait forever. Don't be stuck on something for an hour, 2 hours, or longer. 10 minutes. Think about it 10 minutes and then ask a question. This is also a good time to cultivate your abilities with Googling, right? If you're stuck on something, I'm just going to say this. If you're a developer, if you're coming from a developer background, you know this. As a developer, one of your primary skills is Googling, right? And searching Stack Exchange, Stack Overflow. That it may not seem like that's a skill. It is actually a skill. How do you ask the right question? How do you discern from the things that you're looking through a solution for you particularly, right? So don't stay stuck, right? You don't need to pull everything out of your memory all the time. You're going to build your skills. A big part of your skill base is going to be in referencing outside materials. And throughout this course, if you get stuck, just ask us. If you're stuck for a significantly long time, ask in the channel first, right? Because your peers are going to be able to address your question first. But then, if you don't get a satisfactory answer from your peers, ask us. And, we might set up a 10-minute session with you, like video, just a remote tutoring session, something like that. Or we might be able to walk you through, using the Socratic method in general. That's how we would do it. We would point out something like, hey, did you think about this? Or what about this? What do you think would happen if you did this? In order to lead you toward an answer, because obviously we don't want to be giving each other answers necessarily. We want to be promoting each other's learning. The biggest expectation we have, though, is for you to practice. And attending lecture is not going to be enough to just pass the technical interview unless you already have the requisite skills, right? What's going to get you past the technical interview is practice. And practice can take a lot of different forms. We'll talk about that. And there's a great point. It does take a lot of practice on Stack Overflow to be able to ask questions in a manner that meets their criteria for questions, content, and format. Yeah, that is true. And I think it also takes a lot of practice in Googling, in your Googling traversal of Stack Overflow to find the thing that you're looking for. Like, how do you ask the question that helps you to answer that question? That's actually it's challenging. It's more challenging. You'll see that becomes more challenging the deeper you get into the subject matter. Okay, so our materials, as I showed you, our materials are on Learn, and I just opened that again. And I'm just going to show you the sections. We link all of these. This initialize and onboarding section, I'm assuming most of you have already gone through this. And all this has is, some instructions, course materials, and a schedule for study hall, contact for David Coleman, who's our team admin, some things that I'm already talking about here, right? Slack etiquette, subjects covered, all that kind of stuff. These different sections, let's just do a very quick tour of them. So we've got this welcome to data science prep section. And, if you're like me, this is the first section that you skip and you never look at again. But there are a couple important things in here. In the expectations, we have a lot of information in here on the technical interview. So, we have this expected skills for the technical interview, which has a YouTube playlist embedded into it, which I'm just going to open up really quick on YouTube. This playlist, it's about 10 videos. And what I say to people pretty often is, if you can watch all of this, and all of these videos are like 10 minutes, 10 to 20 minutes. If you watch all of this and you're like, oh, I could code all of this if prompted, you are more than ready for the technical interview. There are also some basics in here that are sort of primers for our technical interviews, right? Like we cover some stuff related to binary, relating binary to decimal, random generation of binary. Those are things that you might see in the technical interview, or looking at the Poisson distribution in videos 9 and 10. You might see those things in the technical interview. So this is a great place to kind of gauge, one of the places you can gauge your skill for the technical interview. We're making more materials in that regard as well, and we'll either update this playlist or information in general in this expected skills section on Learn. So that's where you would find this. I'm probably going to point this playlist out to you more than once. But yeah, this is here. There's also a list of functions that we expect you to know on the technical interview. And not just functions, but the built-ins in general. So data types, operators, functions, right? This is, may seem like a big list, but, when you're in Python, it doesn't really seem that big actually. And, different methods for different data types, list, string methods, tuples, sets, dictionaries. We'll talk about all of that. And then we've got this little section, prepping for the DSI start date. And there are a couple things in here. There's a pre-course. So once you pass your technical interview, you get added to pre-course. It turns out that pre-course is mostly here, right? In the bottom here, we've got this further studies section. Everything that's in here is also in pre-course. Pre-course has a couple extra lessons from this. So if you pass your technical interview and pre-course hasn't opened up yet, you can work on materials related to the DSI. You can get a start on those by getting into further studies and completing those. Although I am going to say, unless you're feeling very comfortable with everything in our intro to Python, intermediate Python, and intro to stats, I would, if you are feeling comfortable with everything there, I would say put further studies on the back burner until you pass your technical interview, and then switch gears to further studies. The other thing in here is this setting up your development environment. It turns out, and maybe Clark can corroborate this from his experience too, environment setup your environment is somewhere like 60 to 70% of your skill in a specific technology, right? Like if you're a Java developer, you're probably going to be using what is it, JetBrains or IdeaBrains? I can't remember. It's been a while since I've done Java, but you might be using Eclipse. You might be using a specific tech stack, and you need to know that environment. You need to know your editors and know, the JVM you're working on or whatever. With Python, there is a lot of environment stuff, right? There's, getting to know your code editor, right? Your text editor, whatever you use. There's getting to know your operating system to the degree that you can support Python within that space. Whether you're using Anaconda or pip or whatever you're using, we use Anaconda, but you need to kind of know Anaconda, right? You're going to get to know Docker. You might get to know Kubernetes. You might get to know Amazon Web Services, right? Or Google Cloud Platform. There are all these technologies that, when combined, that is your environment. And being a developer has so much to do with your environment that I can't understate that. So that said, we do have this environment setup section, and there are going to be some things that you want to do sooner than later, right? So maybe toward the beginning of the second week or beginning of the third week, you're going to want to get your environment set up. And that's going to include getting Anaconda installed and using VS Code or some other text editor if you feel comfortable using a different like Sublime Text or Atom or Vim or whatever you want to use. There's also GitHub. GitHub can maybe wait a little bit, but you are going to be using GitHub constantly for this course because all of our course materials are up there. So this is Learn. All the work that you're going to be doing for this course, almost all is going to be on Learn. A little bit outside of it, but almost all of it's going to be here. Okay. So that's the materials. This prep links document is another thing I need to change because, as I said before, all of our links, everything is on the README for our GitHub repository. So I'll update that after class. We might give some supplemental homework. For the most part, that'll be optional. We might give some quick challenges, like a quick combinations problem or, some kind of probability problem. Usually that's the form. Or, hey, here's this Code Wars challenge that we think is really cool. Try to do it. Try to complete it. And, put your answer here. And, just as a little side challenge. But in general, those will be optional. Let me look at questions. I see a couple questions have come through. Oh, no. Okay, great. All right. So bugs and edits. We make these materials. We make all the materials on Learn. We make all the materials that you're going to see for the most part. We make mistakes and we have typos. And I think I'm the person on our team with the best written grammar. And you might notice at times that that there's some bad grammar, and we very much appreciate you letting us know. You can send a direct message to me or to Lance or to Clark. Really anyone on our team. I think Lance and I usually get to it first. So, if you see, oh, hey, here's a misspelling, you used there instead of there, right? Like, just let us know, and we'll fix it pretty quickly. In any of our materials that we share, if you notice something, please let us know, and we very much appreciate you letting us know. Lecture format, 2 hours, Monday through Thursday, Saturday, right? I kind of already mentioned that part of it. Just so you know, we're not going to review homework in lecture. However, we do monitor the Slack channel, right? So if you're stuck on something, if there's a challenge that you're really stuck on, post in the Slack channel. And if one of your peers doesn't get to it, one of our team members definitely will. We usually give it about an hour before we answer, because we want you all to help each other, right? And to help each other get to an answer. And so if we see something, we'll probably wait a little bit to answer before. And if we notice nobody else is getting to it, any of your peers, then we'll get to it, and we'll address where you're stuck. In general, we'll cover a topic for somewhere around 5. And when I say topic, sorry, we're going to cover a specific concept within a topic for 5 to 15 minutes of lecture. And then we usually have like a 3 to 7 minute breakout where we say, okay, solve this, code this up really quick, something like that. And then we do that over and over and over again. I'm going to say 3/4 of lectures are going to look something like that. My lectures, some of them are going to be heavily conceptual and will be a little bit different, right? And especially toward the end of class, where maybe the intro to machine learning workflow class, that's going to be me live coding a lot and asking conceptual questions as we go. We won't have breakouts in that kind of class, but that's on the rare side. That's really maybe 2 lectures out of all our lectures, maybe 3 lectures if I throw in code this model from scratch kind of lecture, which I'm thinking about doing. We say that we're time boxing questions to 5 minutes. We used to do that, but in general, at this point, we kind of answer questions somewhat in real time. And then if it's a question we can't answer in real time, we'll usually, it says unanswered questions, we can follow up with one-on-ones. Some questions will do that, but Clark and I both tend to stay after somewhere between 5 and 15 minutes after any given lecture. So, we'll usually do follow-up, if we want to jump deeper into a concept or explain a concept that was confusing during that actual class, or if you have questions regarding something else, we'll usually address those at the end of class. So just and we try to have a hard stop right at the hour when class ends, because we know people have bed, right? People have all kinds of things to do. They have lives. But we'll say that we might go 1 minute over, 2 minutes over, something like that. But we'll say, okay, that's lecture for tonight. Have a great night. If you have any questions, stay on and ask them, right? And the questions we'll also record and we'll post to YouTube, unless there's a specific question that needs to be addressed outside of class. Okay, so study hall. We stream study hall to YouTube. Currently it happens 3 times a week: Monday, Wednesday, Friday, 3 p.m. Pacific time. Clark is the person leading that, and he can speak more to that when I hand off to him, or at the end of class today. But yeah, it's mostly working through problems that students bring to the table. It's also, when there aren't students asking questions, it's exploration of some kind of concept. It's more on the basic Python side of things, because we're trying to get everybody up to a level of Python where they can apply their Python in, stats-oriented materials. And I'm probably going to have, I'm not sure if it's going to be every week or every other week, kind of a technical interview study hall as well, where, I stream for a couple hours on something that looks like our technical interview, because, I don't know, it's helpful to people. Anytime I've done that, it's pushed people, focused people's studies and helped them toward the technical interview. We announce in Slack when we go live. Our schedule is pretty consistently this 3 to 5 p.m. Pacific time, Monday, Wednesday, Friday. We do cancel from time to time, either due to holidays or because we have other workload that we need to take care of. So, don't be, but when we do cancel, we'll say something. We'll say, hey, we're canceling study hall today. See you on Wednesday or see you on Friday. Okay, so mentoring is something. Oh, let me answer this question. Is the study hall going to be in Zoom or live streamed through YouTube? It's live streamed through YouTube. And we'll announce it in DS Basic Prep. And students can ask questions in DS Basic Prep that, about a specific challenge. And the way that goes in general is you're on a challenge and learn. You copy the URL and post that and say, hey, I'm stuck on challenge 3 in this lesson, and you post the URL, we're able to open that up right away and say, oh, okay, well, let's talk about this. We'll code through it and come to some kind of solution that works. And, maybe we'll take a couple different angles on it and be a little exhaustive, or maybe we'll be quick, depending on the problem. But yeah, the dialogue can happen in real time though, either way. And that's how and why we do study hall, to help you all have a singular place to go where we can get you unstuck. Okay, so in terms of mentoring, there are times where, we offer mentoring for a number of different reasons. Occasionally, we'll reach out and say, hey, it looks like you're getting a lot done, and let's meet up one-on-one for 15 minutes, and I can let you know if you are ready for the technical interview. So that's one form of mentoring that we do. I tend to do that. A couple other people on our team might do that. There's also mentoring that we'll reach out and say, hey, it looks like you've gotten to a decent level of completion. Is there anything that you're stuck on? And is there anything that you'd like more clarity on? And we might meet up for mentoring for that reason. So these generally look like 15 to 30-minute sessions. We don't record them or anything. In general, we won't record them unless you specifically ask us to, and we are able to do that. But yeah, we just do that to help you get unstuck. And you're probably most people will mentor at least one time. Unless, you breeze through the materials and you feel great about it and you take your technical interview and you're good to go. Most people will mentor one time. And you're probably going to find that to be helpful around, let's say, the discrete distributions, right? Where we are, the crux of our technical interviews are around discrete distributions and usage of dictionaries in exploring them. And that can be confusing. And mentoring can really clarify a lot of things. So definitely try to reach out for mentoring. We'll, if you're stuck in a way that is significant that you're like, there's no way I can do this, we can help you realize that you can do it, right? That's what mentoring is here for. But yeah, in general, reach out to Clark or reach out to me or reach out to Remy. The three of us kind of do the most mentoring, and feel free to email me in that regard as well, and I can get you into our queue for mentoring. Deferring, I already mentioned this. If you're falling behind or struggling significantly in the premium prep and you want to slow down a little bit, defer to the next cohort. You're always welcome to do that. You're welcome to do that as many times as you need to, as long as you're making progress. That's what we care about. It may take you a much longer time if you're moving very slowly on it or you don't have much time to work on it. We just want to see that you're always getting a little bit better. The pace of that, the rate of that is not that important to us. We're trying to get you there. And as long as we see that we're helping you get there, then you can defer as many times as you want. Supplemental materials, I already talked about the further studies section as being parallel to the pre-course. So, getting started on further studies after your technical interview, we're going to recommend that. We usually say that at the end of the technical interview anyway. If you're one of those people who really likes doing a lot of challenging work, we can get you more work. And that's a fun thing for us. So if you're like, yes, I need more, reach out to me, and I will point you at something that will make you not want more, probably. But it's something that we can do. It's something we enjoy doing. I can give you materials to work on if you feel like you don't have enough in front of you. After you pass the technical interview, usually this is me. I'll be available to meet up with you to talk about things that are more domain specific, right? So I already mentioned this: image processing materials or financial analysis materials. I can point you at resources to get started on. Things that are more domain specific. The other thing, and I don't want to say this lightly, it's super, super helpful to do stuff on Code Wars. Okay. So I'm just going to open up Code Wars really quick. And what Code Wars is, it's a massive repository of user-generated coding challenges. And it looks like this. If you go to the link in the slides or the link that we provide in Learn, you'll have to solve a very simple Python challenge, and then you can start doing reps in here. This is if you think about this, think about it like you're doing reps, right? You're going to do a few of these a day, and your coding skill is just going to improve and improve and improve and improve. If you play games like Final Fantasy, other RPGs, there are times where you go and you grind, right? You go and you just battle monsters and increase your XP and your skills and things like that. And you can approach that like this too. Just it's like a game. You look at some problems, you solve them. If you do sign up for this, and I definitely recommend that you do, I'm just going to show you the settings I like using. I like to sort by the popularity of the challenge. I'll set this to Python really quick. So here we have Python, and notice there's like something like 4,000 different challenges in Python. And then I'll set this to a difficulty. Well, I'll set it to probably a lower difficulty if it's me. But for anybody out there, for any of you, the best thing for you to do at this point would be set it to a difficulty of like 8, which is the easiest. And then, you go through and you start solving these things, right? You click on this and you train, and then you're given this thing. I look at this, I'm like, oh, def multiply A comma B. Oh, well, there's an error in here, and it's just missing a return statement. And if I run this, I can hit test. It'll run this against these tests. It's saying, hey, you should write more tests. I'm not going to write more tests, but that's what it's asking me to do. And then I click attempt, and I pass all these tests, and then I submit my code. And if I hadn't solved this one before, then my points would increase over here, right? So easy workflow, and it will improve your skills a lot. It'll definitely get you very familiar with the semantics of Python, and you'll be doing very many similar problems, and that repetition will turn Python into a language that you can leverage with your own creativity. And that's very important, to think about Python as a form of your expression, your creative expression. Okay, so applying for the DSI, we want you to do this as soon as possible for a very specific reason. So our team is an educational team. We are not plugged in that much with the bureaucracy around going into the data science immersive. We are here to shepherd you in terms of skills. There's a person who is available to you to shepherd you in terms of everything else. Paperwork, things like what is it? I don't even remember the name of it. See, this is the thing. If I was an enrollment advisor, I'd be able to say, that program where you don't pay your tuition up front and you pay it, ISAs, that's what they're called, right? Income share agreements. Like couldn't remember the name of that. And that's a large part of Galvanize, right? So, just filling this out, this admissions portal, creating an account, that gets you in touch with an enrollment advisor that you can ask questions of at any time. So I'm going to just drop that link in here in the Slack. And yeah, I just recommend doing that as soon as you can. And we'll do our best to answer questions, but we're likely to forward you to somebody who knows better than we do when it comes to those types of materials, those types of questions. Okay, so the technical interview itself, I'm just going to say something brief about it. It's 45 minutes long. It tests your ability to apply Python on probability and statistics concepts. And we have pretty extensive materials on it. So I just recommend reading through those and reaching out if you have any questions. Our team, we are an education team. We are also the team that conducts the technical interview. The list of names that I provided above were the people who are going to be interviewing you and gauging whether or not you're prepared for the DSI. So you might interview with me or Clark or Lance or Remy or Devin. Jupyter Notebooks. The technical interview is conducted currently in a Jupyter Notebook. We might be moving away from that, but we'll let you all know if we do have any significant changes regarding the technical interview. There is a coding challenge that you need to pass. So that admissions portal that I showed to you, you register and then you basically fill out your application. In order to take the technical interview, you have to pass a simple coding challenge, right? It has you writing 3 functions, and there's automatic tests of those functions. If you have basic Python fairly down, and the basic and intermediate Python, reasonably, if you're reasonably proficient in those, these challenges are not hard. They involve some dictionaries and analyzing basically a numerical phenomenon. Again, the technical interview playlist on YouTube, that is one of your best resources for getting ready. Once you have your Python and stats down, that's going to give you the foundation for the technical interview. What alternative to Jupyter are you considering? We're considering VS Code Live Share. So, in that case, we'd just be working in a shared document with you. We're considering conducting the interview solely out of Learn. So if you're used to using Learn, that might be a way that we do it. I'm thinking about just coding an interactive text editor to conduct the interview. Something where we can have mathematical formulation on the side and a Python runtime. And then we could just share a link to a AWS instance that's running it, or a Heroku instance that's running it. So the thing, we're considering a few different things, and you're probably going to be in a Jupyter Notebook. So, getting, and the sooner that you get used to Jupyter Notebooks, the better. Just saying. I like them, but I don't generally code in them unless I'm, analyzing some data that I've never seen before. Our team, we see ourselves as facilitators, not gatekeepers. We are trying to get you into the DSI. The DSI is really hard, and I'm not saying that to deter you in any way. I think it's well worth how stressful it is. It's a little bit like we always say this thing. It's like drinking from a fire hose, and that's not not that much of an exaggeration. Most people will feel like they are constantly behind in it, but it turns you into a really solid developer. It's kind of wild. By the end of it, you realize you have. So I have this many years of software development behind me, and there was this point because I went through the DSI. There was this point where I was like, oh, give me a new language, give me a new concept in language, and I can learn that in a month, maybe 2 months. Yeah, totally. And then I went through the DSI, and it's more like, oh, you need me to learn this thing? Give me like 5 days, and I got it, And I did that. I did that for a couple of different interviews where they were like, we need you to know this technology for this job, and then I just would learn that within a few days. And you kind of realize that you have an amazing capacity to build out new knowledge and new skills, and the DSI is great for that, and that's why that stress is worth it, in my opinion. Yeah. So yeah, we see ourselves as facilitators, not gatekeepers. We want you to get into the DSI, and we want to help you get ready for the technical interview. We want to make sure that you're ready and that you're going to get the most out of the DSI, right? And that's the only way we gatekeep. It's just making sure that you're above our minimum threshold. There's just this thing. There's this thing called the Beginner's Creed. I'm not going to read through this, but essentially, if you want to read through this, it's somewhat poetic. Realize that you don't know yet what you're going to learn, right? That's kind of what this comes down to. And don't be incredibly worried about your ability to learn. It's going to take time. It's going to take a certain kind of cognitive suffering. That's part of learning, right? And what you're going to get out of this is a new ability to express yourself. If you aren't coming from a coding background, what you learn in coding is a new way to express yourself, where you can have some idea and you can model that idea in a text editor and sort of gauge, bring it back into your real world, right? As an example, I had this thought quite a while back where I was thinking, how do the windows of prime numbers, like the spaces between two prime numbers, what is the distribution of those? What does that look like? And in my brain, I had this small hypothesis like, well, that follows a geometric distribution, which I'm not going to really explain here, but in a way that it's like, well, failure, 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 success, prime, right? And I had this assumption, and it kind of needled at me. And because I know Python, I was able to go test that assumption. What I found out is I was completely wrong, right? That the most prevalent distance between prime numbers is 6 numbers, right? Which is kind of wild. And we can analyze prime numbers over these massive spaces, all over these massive ranges, right? And we can do a very clear analysis. And I'm not like I don't have a PhD in math or anything like that, but I have some not basic Python skills. I'm pretty good at Python, but I have these skills that allow me to ask a question and devise a strategy for answering it. And that's golden. That's a way that we don't generally have. We don't learn how to communicate that way unless we learn how to program, right? And we don't know how to analyze that way in such a systematic and efficient, with such efficient strategies, unless we know a programming language. So the tunnel, the frustrating tunnel that'll get you there is well worth it. And just reminding yourself that you are going to be a beginner for a while is super important in that. There's, that goes along with the idea of a fixed mindset versus growth mindset. Encourage yourself to have a growth mindset. Having a fixed mindset, saying that I am like this, I am this kind of thinker, I'm not good at math, any of those things. None of those things are inherently true, right? Some of us were told that we're not good at math, and it turns out that math is just generally taught very poorly, and that's a lot of us have had that kind of experience, and some of us learned really well through that lens of math. And so part of this growth mindset is looking at other people who don't seem to be that good at math and saying, I think this person has the potential to be really good at math if they learn it in a different way, or if they have this focused form of study, right? But just realize that this is all a process, getting you to where you want to be. And you're going to hit walls. Those walls are your friends. Those obstacles are your friends. That kind of tension is where you learn the most. There's a statement in here. Learning coding reminds me of my kids playing with their Legos. They get familiar with the basic pieces, put together the picture on the box, and then after they're comfortable, they start building stuff that they create in their mind. And that's Yeah, the analogy I make all the time is to Bob Ross paintings, right? If you ever watched Bob Ross, Happy Little Trees, and all that stuff, um, you can watch Bob Ross all day, and it's really nice, actually. Like, you can really watch Bob Ross and feel good about the world in a way that, yeah, it's really nice. And here's part of the reality of watching Bob Ross. You can watch Bob Ross every day for years and years and not become a painter, right? You actually need to paint in order to become a painter. And you can learn all these techniques in by watching Bob Ross, and that's great. And then at some point, you're going to have a body, a sort of foundation of skills that you can use to express new thoughts, and that is really such an amazing thing about coding, is that you can have a new thought and you can model it. And you sometimes will have, you'll come up with something that nobody else has. And in general, you won't, because there's so many of us that you're going to reinvent something that somebody else invented. But you get to have that experience of invention. And that's you get that power, you get that epiphany, and it's really wonderful. Yeah. So in some sense, a growth mindset is like trusting in the process, trusting in your cognitive abilities. Now, this is something I like to harp on, thinking critically. There's this amazing, if you want to have a small existential dilemma sometime, go read this list of cognitive biases on Wikipedia and realize that you probably do so many of these all the time. This is a big list, right? And any one of these, overconfidence effect, right? Excessive confidence in one's own answers to questions. Oh God, it hurts. It hurts a little bit to read that, because I know that I do this. But in general, kind of what I'm getting at is thinking critically is so core to what it means to be a data scientist. And I'll just tell a little story about this. I was playing. There's this game. I don't remember the name of it, where you write down a description of something on a piece of paper, and then you fold the paper over and you hand it to the person to your right, and then they draw a picture of what you wrote, right? And they draw a picture of it, and then they fold that and hand that to the right, and the next person writes down a sentence that is a description of the picture. So it's a kind of a verbal to visual game of telephone. I played this game with six data scientists, and every it was the wildest thing. When the words and pictures made their way all the way around, when you got back to your own one, right? And this is with 6 people, so there's 6 pieces of paper doing this. When it came back, the description of the description at the end was so close to the description at the beginning that they were fairly interchangeable, right? Maybe there was some slight difference. And part of that is how important it is as a data scientist to try to discern what's going on right there. So you're seeing this picture, and you're like, okay, I need to convey this message as accurately as possible. I need to be very critical about how I do this. And that's what you do. And then the next person is like looking at the picture. They're like, I need to understand this and decipher it and try to write down the most accurate thing possible. That mindset is so important for us. And what that means is you go and you look at some data, and you have to ask yourself, am I just seeing what I want to see here, right? And if I am, like, how do I discern that? How do I make sure that I'm not superimposing or projecting onto this in some way? And then the next stage of that is when you work as a data scientist, someone comes to you and they'll be like, oh, hey, here's all my grocery receipts from the last 6 months. Can you predict the value of my stock portfolio in 2 weeks? And you're like, no, I can't. You get this great opportunity to look at what people have as data and tell them, no, the thing you want to do is not possible with what you have here. And that's one of your most important roles. You have to be critical in a way that is, not necessarily definitive, but has an authority that is weighted by the amount of cognitive power you put in to determining whether or not what you believe is correct, right? And that's super important. And I encourage everybody, look through this cognitive biases list and, you know, just maybe make some flashcards out of the ones that really stick out to you and think about where you do that in your life, right? You're going to see that this isn't just applicable in kind of an existential way. It's going to come up a lot, right? And you're going to start, as you learn more, you know, more stats, when you learn more data science, you're going to be reading articles, you know, like something in common journal media where you're going to, your alarms are going to go off in your head and you're going to be saying, this is bad science. You know, what the New York Times is saying right here is bad science, or, you know, whatever you might be reading. Or like, where's the source for this? That's the thing that is going to be firing in your head. If you don't already have like a strong science background, it's really going to start happening. Yeah, develop consciousness of your biases is kind of the second recommendation here. So we looked at learn. I'm going to just point at Replit really quick before I hand off to Clark. Replit, if you've never coded before or you don't have a local coding environment, you're probably going to use Replit for a little bit. So this is just repl.it, and I just ran through that really fast. Let me just, if I open up repl.it, in this top right corner, there's a little plus symbol. I'm going to click on that, and I'm going to create a new REPL. I'm going to use Python, and it's going to auto name it for me. So dark orange, medium blue adware. Okay. And then it sets up a coding environment for me. So there are 3 columns here, files, main.py, and this console right here. I'm going to write my code in main.py. So maybe I'll make this a little bigger. Print. Notice it's giving me auto suggestions. I can print this common thing we call a hello world. And then I can hit this play button right here, and it's going to say hello world. So the output goes out here, right? Hello, hello people. I'll leave it that way. Hello, Pipoli. And yeah, it does that. The other cool thing about this, if you want to code with somebody else, there's this share button. And I need to zoom out a little bit. There's an invite link right here. So if I copy this and I'll put this in, I'm just going to message this to Clark really quick. And Clark can join the space and we can code in the same space together. So this is a nice place to get your feet wet with pair coding, which is something you're going to be doing in the DSI quite a lot, actually. So yeah, this is Replit. It's a fully featured coding environment, but you're going to want to move away from it and start using VS Code before very long. And so Clark just joined. We can see there are 2 people online, and so Clark's doing stuff in there. And we can actually, you know, we can both do stuff. We can be like, right. We can both type at the same time, anything like that. Something to point out though, if you are using Replit, you can change the theme. I like using a dark theme personally. Over here in settings, this cog on the left, and you can change the indent size. You should change the indent size. By default, it's going to be 2. In Python, we use 4-space indexing, or sorry, 4-space indenting. So, you know, that indents me to 4 spaces. Definitely change that. Get used to using 4 spaces, not 2 spaces. 2 spaces is going to be, it's going to be kind of cumbersome. And in Python, we just use, yeah. Is there a way to turn off the helper function in Replit? Yes, and that's what I usually do. It's under code intelligence. You can change it to disabled. Okay, so I'm just about done. Oh, Google Colabs. Google Colabs are they're Jupyter notebooks that live in the cloud, and I'm just going to demo this really quick. You get coding cells and you get text cells, and this is a nice place if you don't get your environment completely set up before you take the technical interview and you want to get used to using Jupyter notebooks. this is a nice place to do that. This works exactly the same as a Jupyter Notebook. It looks slightly different, but not different enough for it to matter. I can write a function here. Let's say def factorial and factorial of n. And let's just code this really quick. Times gets the number, and we can return the product. And I can call this. So I just ran it, and it's not going to do anything because I didn't call it. But now it's in memory, and I can use this. So I can ask, well, what's the factorial of 5? I would expect to see 120, and I do. So this is another coding environment. You're definitely welcome to use Google Colabs. This looks more like what we'll do in the technical interview. But in general, you're going to be using text editors in the DSI, which is more like what Replit is. And ultimately, you're going to be using VS Code for almost everything. Okay, so I think there's one more slide, and that's just Slack etiquette. Just reiterating that. Ask questions in the thread on Slack. If you're answering questions for other people, answer using the Socratic method. Don't just give people the answer. Ask them questions that help them get there on their own. And yeah, that's it. I'm going to hand off to Clark. Thanks so much. I'll see y'all, I think, on Monday. Next Monday is the first stats class, I believe. In the meantime, for the next few days, Clark's going to be building out your foundations in Python before we move to some basics and stats. So let me just check if anyone asked any questions. There's a question, is PyCharm okay? Yeah, PyCharm's okay. We don't use PyCharm in the DSI. There are, how do I say this? There are good reasons to use PyCharm. There are good reasons not to use PyCharm. I like PyCharm. I don't use it. I try to use, a much more raw text editor, either VS Code or Vim, and that's my bent as a programmer. But PyCharm has a lot of bells and whistles, and you can use it in the DSI, but it is discouraged. VS Code is the sort of common editor that Galvanize uses across all its programs right now. Yeah, any other quick questions before I hand off? And I think we'll probably take a quick 5-minute break before Clark takes over. But yeah, if you have any questions, definitely ask them. I'm also going to be back on at the end of class, so I'll be on at the hour to stay after to answer any questions along with Clark. I don't see anyone typing. I'm going to hand you over to Clark Walker, and he's going to take it from you. Thanks so much.
Yeah. Thanks, Tovio. Yeah, let's have a 5-minute break so we can reconvene at, it's 24 after the hour. That'll round us up a little bit. All right, if you can hear my voice, we're about to reconvene. Make yourselves comfy. We'll get started in just a second here. All right, I've got Slack up. If anybody's got any questions, feel free to post them in as we go along. I will take them as I can. We've got a bit to get through, so I'm going to try to kind of keep a pace. First of all, just want to confirm, can somebody put a thumbs up in the chat if they can see my screen? I'm presenting Adam. Good, okay, excellent. Let me kind of adjust this a little bit. Used to the new workflow. Okay, lovely. So this might look a little different, but essentially this is the same thing. Tovio was just showing you the slides like this. I've got my terminal up. This is sort of ready to do some coding. And I'm going to have the slides over here on the right-hand side. Cool, so we're going to be going over just a few things today. What is Python? We're going to be talking about interpreted versus compiled languages. We're going to look at some Python resources. I'll talk about those briefly. I'm going to talk about text editors again, and talk about my environment, what you see up here. We're telling everybody to download VS Code, and this is actually VS Code's open source predecessor, which VS Code is based on, called Atom. This is the text editor that I learned on, and it's my preference because I'm a little bit of a dinosaur and I just love this editor. But y'all should use VS Code because it's essentially the same thing, and you don't have to be a dinosaur like me. VS Code is a fine editor. I don't have anything really against it. I just like what I like. So we're going to talk about a little bit about like programmatic thinking, kind of algorithmic thinking. And then we're going to give some coding examples. We're going to talk about comments in coding. So comments are, if you look here on the left-hand side, I have a document, a Python document. If you look at this, what we have right here, this is a lot like what you saw in Replit. You might look a little more familiar if this were on this side, right? The terminal's on this side. Obviously, this is kind of different output, but this is how I like to set things up for myself. I like my terminal on the bottom. You can do your preferences though. Let's see if I can get that. Oops. Glitches. Okay, so here's my terminal for output. I have a program that monitors the file that I'm working out of and executes the code every time I save it. And that's just because I'm lazy and I don't want to like take my hand from the keyboard, switch it over to the mouse, click on the terminal, enter the run command, and then run it and see it. So I just hit Command S and it just runs it. And it means I can run my code constantly and it's nice and easy. But we don't have to go in that depth of setting up an environment. You can, your environment's going to look different, and over time you're going to kind of find little tricks and little tools that are going to help you set it up the way you like it. Doesn't have to look exactly like mine, but yeah, anyways, so comments got off. This is just a little bit of code. This is similar to Tovio's example in Replit. Here we have our text document and then our output down here in the terminal. But comments are going to allow us to write comments that are for us, not for Python, right? So if I want to say this is an example of the print function, this is not valid Python code. It's hopefully a grammatically correct English sentence, although I have my doubts just from my own history. Quick disclaimer, I am dyslexic, unironically. You will see me misspell things. I know that bothers some people. I'm sorry. I'm going to do my best. If you need to point that stuff out, just be nice about it, and I'll do my best to like keep everything kosher that way. But yeah, anyways, let's get into the material. If I can control my mouse here. All right. So what is Python? Python is a language that is considered general purpose. It's considered a general purpose programming language. It's often used for developing web apps and software, even potentially desktop apps or mobile apps as well. Excuse me. For writing scripts to automate operations within operating systems or other programs. So you may have heard the term like a scripting language. The context of the context for that is that scripting means you have another program, including an operating system. You have another program and you want to like give it scripted commands, like for example, well, a web browser, or say you have a spreadsheet program and you want to automate some task in the spreadsheet. Well, the spreadsheet may be scriptable with a given language. So that's what scripting is. So Python can be used for scripting. It can be used for automating and operating robots and other technical machinery, and obviously data science and more. So general purpose is in contrast to another category of languages, which is domain specific. So you will encounter domain specific languages. An example would be SQL. Presumably many of you have heard of SQL. To juxtapose what it means to be general purpose versus domain specific, SQL's job is to deal with database queries, to query databases, to alter databases. Its job is solely to do with databases. So you can't make like a web app with SQL. You can, however, have it's called an ORM library. It's a type of library which many languages have, and there are many options for Python, but you can have a tool for a general purpose language that automates and compiles SQL for you, or you can handle SQL in Python, right? So you can get Python to do a wide variety of things, whereas something like HTML, Markdown, SQL, those are only suited for the thing that they were built for. They have one job and that's all they can do. So if you hear that term general purpose versus domain specific, that's what that's referring to. Python for data science. Python is one of the many languages used in data science and machine learning. By far the most popular. Some of the reasons for its popularity is that it's easy to learn, read, and write. So a lot of people are coming from technical backgrounds where maybe they learned in an environment. They have significant education in higher math or science, but they learned in an environment where they weren't using a lot of programming. So you need a language that's going to be approachable and not require a computer science degree or a deep understanding of the mechanism of your computer. That's just going to give you like a simple well-designed algorithmic language that you can implement your algorithms in. So Python lends itself well to the scientific community and a lot of other communities because of that, because it's very approachable. So there's a lot of infrastructure built, or what I would call infrastructure. I'm stretching the term honestly, but extensive scientific computing libraries and published academic work that uses Python. So the extensive scientific computing libraries such as NumPy, SciPy, scikit-learn, etc., things like that you might have heard of. And those are very well established in the domain of Python. Okay, this is just talking about REPL a little bit. I think Tovio covered everything I would like to cover on this. It's just a good soft landing point. If you're new to coding and you don't have an environment set up yet, go ahead and go download VS Code. Some people find it easy to set up and start working with it. You may find that you hit a wall and you're not quite sure how to use it or how to set it up. That's fine. Go download it and give it a shot. But until you get that set up to the point where it's working and easy for you to use, Replit is really nice because it's just a URL. You just go to the URL and you can start coding in the editor portion, and then you hit the run button. You just click the run button and you see the output in the terminal, much like I have here. So it's a really easy starting place. I also like it for when I meet with people I'll usually send, in a mentoring session, I'll send a Zoom link, and then I'll send a REPL and just an empty REPL, and it'll be a place where we can share code and look at that. Thoughts on Xcode? That sounds familiar. I don't know anything about it. At the end of the day, like, you do you. Like, if there's, I mean, if I were going to go through a academic coding program, I would use Atom unless there was some very specific feature that I needed for VS Code, because I like Atom. The reason I like Atom, the reason I would use it, is because it's a tool that I'm very familiar with. And it just, I don't know, honestly, this little text editor just warms my heart, and I love it. Kind of in a, like one would love a puppy. I'm just attached to it, maybe unreasonably, but so if there's an editor that you really love, that you know really well, yeah, I mean, do what you know is going to work for you. In terms of, like, if you're at the stage where you're like, I'm looking for a tool to start with, just use VS Code. It's basically, I mean, it's industry standard, and yeah, across the board, not just in data science. Okay, cool. Thank you, Tovio. Cool. Oh, that Xcode. What am I saying? I'm like, what is that? Gosh, I'm like, I don't know what's wrong with me today. Yeah, I know what Xcode is. Yeah. Yes, what that other comment is. Yes, I echo that sentiment as well. All right. So Python is an interpreted language. There are language. So when you talk about a programming language, you kind of have to separate the idea of there's a standard for the syntax and the semantics, and then there's a program that examines that syntactic and semantic structure for validity, and executes the code in some way, right? So there are two ways you can write that program. One is interpreted, which is what Python is. The interpreter is a program. So you have a Python interpreter program. I'm going to show you how I use it. So I'm going to use my Python interpreter here. I'm going to say the Python interpreter that I use is called IPython. So I'm going to say IPython 3. And if you're not familiar with how a terminal works, I'm just specifying the name of the program that I want to use here, which is IPython 3, and then I'm going to provide a name for a file for it to execute. So in this case, I'm going to say day1 lib .py. And lib is short for library. Day1 lib.py. I'm going to execute that command. Does not exist. Oh, right. Because it's actually in a directory. It's in src/python. There we go. So I was in the wrong location. Okay, so you see it says hello here. So that means I got the output here. So what I usually do, oops, a little glitchy. I usually use this, like I said, a file watcher. The file watcher program I use is called NodeMon. It takes a little bit of setting up. It's actually a tool from JavaScript that I picked up when I was doing JavaScript, and I like to use it for everything. But anyways, so IPython, I just wanted to show that because I wanted to show an example of utilizing the interpreter directly, which is IPython 3. So that's a program that's going to look through the document that I tell it to look through, and it's going to start at the top, just like you would, if you're reading a book or something, it's going to start at line 1 and go from left to right and execute the code, presuming that the code is valid, right? So if I type invalid code, if I leave off that parenthesis, you can see it kind of breaks my syntax highlighting. Hold on, let me blow up that text. It might be a little bit small. So if I delete that or make some invalid code, I'm going to get an error. It's taking a second to run. I got an error. Says unexpected EOF while parsing. EOF is the shorthand for end of file, right? So it sees that the file ended and it was expecting this function call to be completed, which I didn't do, right? So I want you to bake this idea into your minds as soon as you can, right? Errors don't mean you're a bad programmer. You're going to see me and probably Tovio get errors completely on accident, where we're going to say, hey, look at this example code. I'll just write this thing, and then it'll get an error, and we'll be like, oh, what happened? Because that's part of programming. That is like your job as a programmer, as somebody who's writing code, is going to involve your code getting errors occasionally. I have some people who, quite a number of people that I've interacted with in mentoring sessions say like, yeah, I'm still getting errors. So I don't know if this is for me. And I'm like, I mean, I've gotten errors as long as I've done this. Everybody that I know gets errors all the time. The trick is to learn to utilize them, so you just learn to read them. And if you really sink into learning to read the errors and using the errors, they can do a significant amount of your job for you, and they can really make your life a lot easier. And Python has well-written errors. So if you think about it, some developers somewhere worked really hard to make Python have this error, and that's not because they wanted to punish you. That's because they wanted to make Python development easier, right? So errors are good. Yeah, so get a lot of errors, I guess. All right. Okay, apologies, I got off on another tangent here, but we were talking about interpreted versus compiled, right? So I'm just showing you how this interpreter is going to go. So you might have heard of source code, and you might have heard of executables or executable code, right? So in an interpreted language, the source code is the executable. So this is the source file where the program is. In this case, it's just a simple little program that just prints hello to the terminal. It displays the word hello to the terminal. It's not much of a program, but so the file where you write the code is the file that's executed. So they're one and the same thing. So interpreted languages are kind of simple and easy to start off with. They tend to be high level in the sense of they're abstracted away from the mechanics of the computer, from the mechanism of the machine of the computer, and they're abstracted away from the machine into the world of what humans are more able to think about and deal with in a programming language. So compiled languages such as C, C++, Java, Scala, and Rust work a little bit differently. You write the source code, you use a program called a compiler, which examines the document in much the same way that an interpreter does, although there can be some significant differences. But basically, it's going to start at the top and scan it, make sure the syntax is valid, and then scan it and register all the functions and variables, and then it's going to go through and determine how certain things are going to be executed. And what it does is it produces another file that is executable. So that file can be executed, and it's that executable is either run in its own sort of interpreter, its own virtual machine, such as in the case of Java or Scala or other languages. So that executable can be run in its own virtual software environment, as in those cases, or its environment can be the literal hardware, as is the case with C and C++ and Rust, where you compile those, you get an executable file, and that executable file, when it runs, there's not a software layer that's making decisions on a software level about what that executable should do. That executable communicates directly with your CPU, your RAM, your hard drive. And that's what we call lower level, right? So you'll hear us use the term high and low level. This can be a counterintuitive juxtaposition or a counterintuitive set of terms. Low level means closer to the machine, closer to the hardware. High level means further away from the machine, closer to you as the user. Yeah, it doesn't mean, I think it's easy for people to hear high level and think that means you have to be advanced to understand it. It's sort of the opposite. Documentation. So I'm just presenting my, let's see if I can do this really quick. I'm going to put these into Slack really quick, the links here. So this is for, oh shoot, that's for the PEP8 style guide. And this is a link for the Python 3 official documentation. Both of these are great resources to learn about Python. When you want to read about some tool that you're trying to, maybe you're reading somebody else's code and you see that they use, let's say that you see that they use a function that you haven't seen, like the ID function. You're like, what's the ID function do? So you can go look it up in the internal documentation for or the official documentation for Python. So that's it's a really useful set of links. If you're bored and you're tired of typing out things and coding, but you want to do some studying, just reading the documentation and kind of perusing it, even if it doesn't totally make sense. I've had weird stuff where it's like I read something when I was first learning, I would read something and just kind of perusing documentation, and it wouldn't make any sense to me. And then months or even years later, my understanding would grow and become more advanced, and then whatever I read would just, I'd remember it and I'd say, oh, that must be what that meant. And so you can still build sort of the foundation for understanding things later, even if it doesn't all land now. So reading documentation can be really useful. Also, the style guide is a good place to go. So coding style is things like when you indent, Python by convention uses a 4-space indent, right? So there are certain parts of your code where you need to indent your code. It's necessary for you to indent the code. You can use any amount of spaces to do that, but the preference is to use 4 spaces, and that preference is set by the PEP8 style guide, right? It doesn't mean that you have to do absolutely everything that PEP8 says all the time. I personally diverge from PEP8 in certain circumstances. For example, if you look at this hello right here, it has these quote marks around it, which is what tells Python that this is a string of characters. In fact, this data type is just called a string. I prefer to use the double tick quotes, but you can just as well use the single tick quotes. Single tick quotes are the Pythonic PEP8 preferred way, but I prefer double tick quotes, so I use double tick quotes. So you don't have to, if there's some stylistic choice that you want to make, the most important thing to remember is just be consistent. You can diverge and have your own coding style, and you will. It's at the point where everybody on my team, if I'm looking through our code bases, I can tell who wrote what based on the way it's written. There are just little eccentricities. For instance, I tend to put extra spaces in my function calls like this. That's not necessary. It's not PEP8. PEP8 doesn't tell you to do it or not do it. It's just a stylistic choice that I think just kind of gives the code some visual relief, some breathing room, a little extra space, makes it look a little nicer, makes it a little easier for my dyslexic eyes to parse visually. So if I commit code to like this to our base, somebody would be able to look at it and be like, oh, well, Clark probably wrote this because it looks like Clark's code, and I can kind of tell what Tovio's code looks like. So you'll develop your own style. The value of PEP8 is to get ideas, because they'll talk about like standardizing things in a certain way that maybe you wouldn't think of, and that can really help beautify your code. Which can make it easier to read and write and maintain. So it's a lot of value in putting some effort into understanding coding style. Doesn't have to be a lot, just a little. So I would say give that a read as well. Cool. So text editors, we've talked about text editors, environments. If you have like I said, if you have a tool that you know really well, great. Use it unless there's some reason why you absolutely have to use something else. If you're looking for a tool to start with, VS Code is what you should be shooting for, in my opinion. I'll frame that as my opinion because that's what it is. Oops. And if you don't have VS Code set up yet, you can start with Replit, which is going to be really similar at the end of the day. Anaconda, this talks about Anaconda in the text editor section. Anaconda is not a text editor. It is part of your environment, though. So when I gave that IPython example, IPython is a it's a well-built Python interpreter that a lot of people like. And this is part of Anaconda. When you install Anaconda, it installs IPython and it installs a whole bunch of other tools. It installs a bunch of libraries, NumPy, Matplotlib, I think SciPy, Pandas, Jupyter Notebooks. All when you install Anaconda, you get all of that, right? So those are all tools that we're going to use in developing Python as we go. So Anaconda is like a whole suite of programs that are useful for Python development. Okay, so let's get into a little bit of algorithmic thinking. So step one, how to program, think about the problem. Step two, define what it means for the problem to be working. Step three, create a series of formal steps that lead to a repeatable operation. Okay, so thinking about the problem, broadly define, and I would add to this, like in generic terms, right? In generic terms, try to be as generic as possible. Sometimes it helps to be specific, but you don't want to solve a problem that can only, I don't want to write a function that adds numbers but can only add like 2 and some other number, right? Then it's just going to add 2 to some other number, right? Or it can only add 2 and 5 together. I want to think, how would I do this? How would I add 2 numbers together? And it should work for any 2 integers, right? For example, that'd be an example of like defining in general terms or a broad definition. So try to get as generic of a view as you can of the problem. Yeah, so broadly define what it is you're trying to do, what you want to end up with, right? Does the problem have a specific outcome that you want to obtain? What does it mean for the program to be working? So define, like, think about a success criteria, right? Think about some criteria that tells you that you're finished, that you've ended up with what you wanted. And think about how to test that. You might write a program that takes in a list of numbers and returns a list of numbers where all the numbers from the input list are squared, right? So you might think, well, if the input list has 2 and 4, then the output list should have 4 and 16, because that's 2 squared and 4 squared. So you might think about something like that as you solve that problem. So define what it means for the program to be working. Think about that end state that you want to get at. Think about where you want to end up. If you want a tangible example for this, and I think this is a really, really important step, very important. If you want a tangible example, way of thinking about this would be like, let's say you go on a trip to a new city, you're staying in like an Airbnb or a hotel or something, and you want to go get some groceries. You have to have some way of establishing where the grocery store is, and some way of establishing how you're going to travel there. Are you going to drive? Are you going to get a taxi? Are you going to walk? And you have to know where it is, right? You have to, if you're going to walk, especially, you have to know where it is. You don't leave your room without first figuring out where the grocery store is. If you do, then maybe the goal of going out isn't really to go get groceries, it's to explore, and maybe you ask somebody along the way. Maybe you're just going to go bump into a grocery store, but that's the same kind of thing. You want to determine where is it that I'm trying to end up before you leave, and then along the way, you may not know exactly the way to get there, right? The directions might not be obvious, or they might be obvious, but maybe there's construction along the way, right? Maybe you encounter something along the way that isn't clear, but you still know where you need to end up. So there may be multiple paths to figuring that out. So in terms of problem solving, it's important to take that step of, okay, where do I want to end up when I'm done with this? And then the process of figuring out how to get from where you're at to a solved problem is the process of solving the problem, i.e., it is the process of walking from your hotel room to the grocery store, right? So you don't have to fully, what I'm saying is, I want you to remember this, you don't have to fully conceive of a fully realized solution before you start your solution. All you have to do is know where you want to end up, and then head out the door, right? Then you just start coding, and you might get some errors along the way, but if you just keep the process going, you'll get to where you want to be eventually. So, anyways, create a series of steps for a repeatable operation. So this is in slight contrast to what I was saying about not having a fully realized solution. This is more just, I would say, think about things algorithmically. Like if you were going to write down a set of steps on how to do some task, what might those steps be? We've got about a minute left. So we don't have time for these breakouts, unfortunately. I would suggest going through these as just a little exercise. Feel free to post them in Slack. An algorithm for boiling a box of spaghetti. So feel free to post them in the class thread for today after class. You can do it tomorrow or whenever, or not. But it'd be good to see people's answers to this, just to see that we're probably going to have a pretty divergent set of answers. One person's answer is going to be probably pretty different than somebody else's. So it'd be good to see multiple solutions to that. I did talk about comments. I talked about what they're useful for, but I didn't get really into those. So I'm going to go over the last part. We'll pick it up from comments tomorrow for class tomorrow. And with that, that concludes the time we have. Hope everybody enjoyed. I think Tovio is back on. Yeah, Tovio's here. So we're gonna stay on for questions. I know it's pretty late for some folks. So if you want to wrap up your night, then I'll see you later. We'll see you tomorrow. And have a good rest of your night. And if you want to hang out and be present for people asking questions or ask a question yourself, feel free. We have a question about where we can find the breakouts. Apologies, let me paste these in. I think that's the easiest thing to do. I believe Tovio shared a GitHub repository that's going to have all of these slides that I was presenting on the right-hand side. It'll have all of those slides, and they'll be viewable in GitHub, as well as all of the code that I produced for a given class as well. Tovio, are you pasting that in?
I just did, yeah.
Okay, good.
I'll try to answer that next question. When will today's lecture be up? So this is the first time we are hosting the videos on YouTube. We were hosting them on Zoom, but Zoom has some complications in that regard, and we're just going to start syncing them to GitHub. So once Zoom finishes processing the video, I'm going to download it and put it up to YouTube, and then it probably is going to take a couple hours to process up there. Since we've only done that in a limited capacity up to this point, I'm going to say tomorrow afternoon. I think because I'll probably push it up tomorrow after it's done processing in the morning. So I think in general, lectures should be available by the next day afternoon. That's my general response to that. I think that's probably true. And we'll do our best to stay on that too. There's a question, can I run the Python extension in VS Code on a Mac OS? Yeah. VS Code is going to work on any platform. The specific Python extension, that's a good question. I'm on a Mac and I use a Python extension. I think I use the Python extension, I'm pretty sure. So yeah, I think the Pythons are cross-platform in general.
Yeah, I think everybody on our team, well, no, I guess 2 people use Windows.
Or Linux.
3, yeah. I usually use Linux, but yeah, everybody uses a Mac.
Yeah.
I'm using a Mac right now.
Awesome. Does it matter how old the Mac is? It might. Here's an interesting terrible thing. The new Macs, their M1 chips are not compatible with Docker currently, and so we've been having to, at least with the current cohort, we've been having to say, okay, look at pre-November Macs, which is kind of a strange thing to ask people to do, but yeah, let me see. One of the computers I have, I think has like 16 gigs of RAM and 250 gig SSD, and it's probably from 2015. And that Mac would be sufficient for the DSI. It would be fine. And that's the thing. It's more the RAM matters, the processor matters somewhat. and that you have enough hard drive space matters. In general, minimum specs, I would say 16 gigabytes of RAM, running, like a decent i7 through an i9 somewhere. Like the processor isn't quite as important, but I would say Intel for sure is preferable to AMD. And what was the other aspect of that? Try to have at least 250 gigs hard drive space, and 500 would definitely be preferable. Equipment suggestions. Here's my general suggestion, and take it with a grain of salt. Look at the Ubuntu compatibility list, and you're likely gonna see a lot of Dells on there, and like a decent Dell laptop with like 32 gigs of RAM and 500 gig SSD. I think that machine running Linux is well more than enough power. And the reason I suggest that is Macs are expensive, and what you can do on a Mac, even though it might be streamlined and installation is easier and things like that, it's kind of great using a Linux machine, right? Running Ubuntu or Xubuntu or Mint, some flavor of that is close enough to Ubuntu. The installation, you might need to do a little more troubleshooting here and there for some aspects of your environment, but all of these technologies are primarily or sort of first leveraged on Linux, and then immediately are available on for a Mac, and then may or may not be available for a Windows machine. So I would say check compatibility with Ubuntu and get a more powerful Ubuntu laptop than the equivalently powered Mac. Although getting stuff set up on a Mac is easier. And I can confidently say that if you get a Mac, your setup process will be easier.
Can I chime in on that?
Yeah,
there's a company, System 76, that makes Linux laptops. You can have it shipped with Ubuntu or their own Ubuntu derivative, which is called Pop OS. I've used a number of Linux distributions. I've used Pop OS in a virtual machine, and it for every inch of it, I think it's just a rebranded Ubuntu. So I imagine it would work fine in the DSi, unless Tovio, maybe you know something that I don't, but I think it's just it's their own version of Ubuntu. But if you want Ubuntu on it specifically, they will ship it to you with Ubuntu. But they make pretty good hardware. I think they make really good hardware, and I think they have a good reputation. They're cheaper than a Mac. You spend less and you get more. You get a computer with comparably higher spec for what you spend. So that's a good option if you want to buy like a new computer with Linux on it. It's a little more streamlined. That is what I would personally do if I would get a System 76 computer, and they have a lot of good options. And I think regardless of whether you want to go with Tovio or my recommendation, I think the thing to look for, and maybe you'd want to chime in on this, Tovio, is of any common spec. First of all, Windows is kind of a limitation, so probably either choose something that comes with Linux on it or is highly compatible with Linux, is easy to install Linux on, and where everything's going to work easily. Not every Windows computer will receive Linux well. Some will break and will never boot up again. That's rare, but that can happen. So stick with either Linux or Mac. So that's the first thing. The second thing, I think the most important spec is RAM. I think if there's one rule of thumb, it's get as much RAM as you can afford. I'm looking at a System 76 machine myself that has 64 gigs, and I think, Tovio, you said that I think that would be enough, but you feel limited by that. And then
I don't feel limited by 64 gigs of RAM.
you don't. Oh, I thought you had said that. Which I was like, that's pretty. That's a lot of RAM.
No, the thing is, I was eyeing. This is gonna sound dorky. I was eyeing a machine from a Linux laptop manufacturer that had 128 gigs of RAM, and I just thought that was ridiculous, and I kind of wanted it for the ridiculousness of it. Right? You could pull an entire operating system into your RAM and run it in your RAM. Right? Like that. That to me, it's a little silly. But let's like the clear thing here is that your bottom line should be, can you run Zoom and do everything else you need to do? And that kind of puts you at a base level of RAM of 16 gigs. There was a follow-up. The program you're working with wants you tech compatible for 2 years, not only for this course but for the DSI, right, and a position in a subsequent course, right? So for our course, if you can run Zoom and a text editor, you're fine, right? That's sufficient for us. That probably, you could probably get away with 8 gigs of RAM and be fine. That's probably fine for our course, this current premium prep course. The DSI, 16 gigs minimum, and if we're talking about subsequent courses, I think if you were to spec out to like 32 gigs of RAM and 500 gig SSD, you don't necessarily even need good NVIDIA drivers for GPU stuff, right? Or you don't need a good GPU. Like I'm on a Mac, my like it has decent GPU, but I can't really leverage it with with TensorFlow or PyTorch. And instead, I spin up stuff in the cloud when I need to do that. If I need to do it with a lot of power, right? I'm not using the built-in GPU. And that's a more common paradigm, right? You could have a machine that has like I don't know if you're familiar with a Titan. We buy Titans sometimes for like massive machine learning operations. They're really powerful. Or you can just rent out for like $5 an hour a machine on AWS and do it there. So instead of $10,000, it's $5 an hour. So yeah, I would say 32 gigs of RAM, an i9 or equivalent, or a reasonably decent processor. You're going to be fine. And yeah, that's my thought on it. You can probably get something refurbed for a decent price that would meet all those specs. That's interesting. NVIDIA does not play well with Linux. AMD GPU cards are best for Linux. Yeah, this is the thing. The reason why I say NVIDIA cards, it's the support for PyTorch and TensorFlow. And so very often, the best machine learning laptops are fairly decent gaming machines with NVIDIA cards that you've gotten CUDA to work, and that is the common paradigm. And you can have like a kind of beat up old gaming machine with like a 1070 NVIDIA 1070 in it, and RTX 1070, and that will blow my spec'd out MacBook Pro out of the water, just out of the water, right? Yeah. Oh, there's a statement here. This is good to know. Docker has a beta for the M1 chip. So if you're looking at a new Apple laptop, yeah, we have a document on this. So if there is going to be Docker support for the M1, sorry, let me say this. I don't doubt that there will be Docker support for the M1 for the next cohort, for the May cohort. We've had to encourage people not to get new Macs for this cohort, but I imagine Docker is scrambling for that support. So yeah, that's probably not going to be a limitation pretty soon. Yeah, thanks for that. Yeah, that 2 cents I think is worth a lot more than 2 cents. I think I just mentioned, yeah, because all of us are looking at the future right now. We're all looking at May. We're not really thinking about the current cohort. Yeah. Yeah, do some hardware research, and if you don't feel comfortable with Linux, that is a big hesitation for a lot of people, right? Because if you get into the DSI and you're learning Linux 2 weeks before the DSI starts, and you're trying to make that happen and learn data science, it becomes kind of a lot. Not saying it's impossible, but y'all have a lot more time. You could get into Linux sooner than later, and really see if that's the way that you want to go forward. Yeah, and some of us, like Clark and I, have been using Linux for both of us, a long time, in various domains. So yeah, I think it would be too much to learn both of them at the same time, and it's probably much easier to go with a decently spec'd Mac.
I will say you kind of gotta. I absolutely love it. My Linux machine is out of commission right now due to a hardware issue, but it's my preference just as a daily driver. Just yeah, it's really nice, but there's definitely a learning curve. So yeah, I think it's worth it, but also you really want to take that on while you're like in the DSI. Maybe pick your battles one at a time.
So there's a couple things. Is that why the Mac works so well for the DSI? Because it's Linux based. Yeah, I think because it's Unix based, it's all of these technologies are mostly built with Linux and Unix in mind. And so I think because they're developed for Linux, it's easy for them to be well supported for a Mac. Mac is also so easy to install software on, and that is a big value proposition for a Mac. You just get your environment up and working. You can get your environments very portable quickly. So I'm not making a pitch for Mac versus Linux or anything like that. I think either way is really good. I think Linux is better in some ways because it's more cost effective. It also gets you into the Linux world, which is valuable in and of itself. It's just if it comes down to the wire and you're trying to learn Linux, a Linux machine and data science at the same time, that's a lot, right? And that's a great question. Is there a document on equipment requirements for the prep DSI? So for prep, let me just say this, for prep, our hardware requirements are very minimal. Our hardware requirements are that you can access, that you can use Zoom, right? That you can access Learn and complete challenges on Learn, and that you have a text editor somewhere. That text editor can, you could literally be in this class using a tablet or an iPad, and using Replit and some version of Zoom. I've never used Zoom on a tablet. I assume you can. Wow. Yeah. I don't know. I don't use. Yeah, that's funny.
You definitely can. I have.
Okay. Great. Yeah. Great. Wow.
I've used it on my phone and it's fine.
Okay. Yeah. If you really were tenacious about this, let's say you could use Zoom on a phone and use Replit in a browser on a phone and Learn on a browser and a phone for prep. I don't recommend it, but you could do that. For the DSI, I believe there is an equipment requirements doc, and I've basically stated the requirements. For the machine: 16 gigs of RAM, a modern, preferably Intel processor, and running Linux or it's a Mac, right? But I'll put in a request for that document, for a specific document. because it sounds like y'all need to know those specifics. So I'll ask our team lead to put that together, or to get me something that looks like that. There's a question: will I be good with the 2017 MacBook Pro i7 16 gigabytes for the DSi? I believe that'll be fine. Yeah, I don't see why that would be. I don't, it may not be as fast as you could be. You might be waiting for a couple things here and there, but I think that would be sufficient. A 2011 MacBook Pro i5 with 16 gigabytes, that might be a limitation. And really, I think it's just because of operating system support. Are you running it? If you're able to run Catalina on it though, or Big Sur, that might be okay. But I kind of doubt you can run Big Sur on that. Maybe I'm wrong. Yeah, I'll put in a request from our team lead for that document, because I know there's something out there somewhere. And y'all can't be the only ones who need that information. So I'll just put in that. I'll ask about that. Yeah, it sounds like your machine is going to be fine for the prep. But if you're, it's probably not going to fly for the DSi. Now, if you put Linux on that machine, I'm not recommending you do so, but if you put Linux on that machine, it would probably be fine for the DSi. I might be wrong on that as well, but I think an i5 might be okay.
Spec wise, I would say yeah.
That's what I mean. Yeah.
Compatibility wise, you got to be. It's real hit or miss with that era of Macs. Some of them, it's like you install Linux on it, everything works out of the box, and it's like a brand new computer. And some of them, you like boot lock the thing, and you have to like start over. So just research be as specific as you can and research it before you do it. But yeah, what were you saying, Tovio?
I feel like I have some memory of you frying a Mac from that era. Maybe
I fried an Acer netbook from 2008. I almost boot locked I got my Mac into a boot loop, and I somehow got it unstuck from that. But yeah, I narrowly averted disaster on a 2010 Mac. But I seem to recall like something weird, like there were 2011 models that were fine, and then the particular era that I had in 2010 was not. It's like on and off. You really, some of them are great and some of them aren't. So it's weird.
So let's go ahead and call it here. If you have other questions, ask them tomorrow night, or put them in the Slack channel. Have a great night, everybody. Thanks so much, and we're gonna do our best to get you there. So thanks so much, and see y'all really soon.
Later, y'all.